Okay, this lesson is all about the basics of a matrix arithmetic. So as we get started here, I first wanted to start with one vocab word, which is the dimension. So dimension, also known as the size of a matrix, is going to have m rows. Remember, rows kind of go horizontally, and n columns. Those are going to go vertically, which is known by an m by n, also written m times n. So identify the size or dimension of each matrix. So this one, as you can see, there's 1, 2 rows. So it's a 2 by, then you cut the columns 1, 2, 3, 4 columns. So it's a 2 by 4. This next one, since it has 2 rows and 2 columns, it's called a 2 by 2. This next one has 3 rows and 2 columns, so it's a 3 by 2. And this last one has 4 rows and 1 column, so it's a 4 by 1. The reason why I show you the dimensions to get us started is because whenever we're adding or subtracting, you have to have 2 matrices that are the same size. Then, to add or subtract those matrices, you just add or subtract the corresponding entries. So like almost like the cells of the 2 matrices. So as we look at this first one, you can think about it as such. First of all, this is a 2 by 2. This is a 2 by 2, so we are okay to add them. So the resulting matrix will be also a 2 by 2. So it'll be like 2 entries in each row. So in order to do that, we're going to take the first entries in both matrices, and we're going to add 5 times -1, and we get 4. And then we look at the next one, and we're like, okay, 6 plus 4 is 10, and that's the next entry. And then I do the next one, and I do 3 plus a -5, and I get -2. And then last but not least, I have -2 plus 3, and I get 1. So your final answer here would look like the matrix down here at the bottom is this 2 by 2 matrix that has these 4 entries. Okay, let's look at the next one. This one is a 3 by 2 and a 3 by 2, so we can subtract them. The only difference here is rather than us adding, we're going to do -4 minus a -6, so really think about that as -4 plus 6. Is 2. 6 minus 2 is 4. 2 minus a -3, so really like 2 plus 3 is 5. 1 minus 5 is a -4. -5 minus a -1, so -5 plus 1 is -4. And 3 minus 6 is a -3. And this is your answer. Okay. This one is a 4 by 2, and then I have a 1 by 3 and a 1 by 3. So while I could subtract these 2 1 by 3s, I cannot then subtract it from that 4 by 2. So if you cannot do it, we often call them undefined. The other way I've seen people call them is like impossible, but basically no, if they do not have the same dimensions, you cannot do it. Okay. So critical thinking, let's think for a minute. Which will hold true with matrix addition? If I switch the order, like for example that first one, I had -1 plus 5 rather than 5 plus -1, would it still be the same? And the answer is yes. As far as associative, like grouping 2 things together and then the next 2 things together, this will still be true. The identity property is if we took some matrix A and we added 0 to every single element. So you often call that like the matrix 0. So this is a matrix, right, with all zeros. Or if we did that opposite, right, commutative property 0 plus that matrix, we would get out the matrix. That does work. And then is there some inverse? So the inverse property for addition would be if I took my matrix A, like let's say it was the matrix 2, 7, 3, 4. Your inverse of that for the additive property is just -2, -7, -3, -4. So you could just add a -a. And all your regular properties that hold true in our base 10 system also work here. Keep that in mind though, because in a minute that may not be true as well. Okay, so let's look at the next part. The next part is scalar multiplication. Here is the idea is that we're going to have some coefficient. So in this case, we've got a -4, and we're distributing that to matrix A. So matrix A is 3, -4, 7, -1, 6, 0. And what we do there is we take this number out front and we multiply it by each of those entries. So like -4 times 3, -4 times -4, -4 times 7, -4 times 1, -4 times 6, -4 times 0. And our answer would result in -12, +16, -28, -4. Oh, sorry, that should be a +4 because that's a -1, my bad. And then -24. Be careful, I accidentally ran a 7 there. Make sure you didn't do that. And then 0. And that's our final answer. So when we're doing 7 times C, we're doing 7 times each of the elements in matrix C. So 7 times -10 is -70, 7 times 0 is 0, 7 times 5 is 35, 7 times -6 is -42. Okay, twice C minus B. So if I do 2 times C, I don't think we need to write the 2 up front. I think we can skip that, right? So let's do twice C. So twice -10 is -20, 2 times 0 is 0, 2 times 5 is 10, 2 times -6 is -12, and we're then going to subtract matrix B. So now we do -20 minus 9 is -29, 0 minus a -8 is really a +8, 10 minus 3 is 7, -12 minus 2 is -14. Okay, and let's do the next one. So 3 times B. So if I do 3 times 9, I get 27. 3 times -8 is -24. 3 times 3 is 9. 3 times 2 is 6. And then I'm doing 2 times C again. 2 times -10 is -20. 2 times 0 is 0. 2 times 5 is 10. 2 times -6 is -12. Okay, 27 minus 20 is going to be, or plus a -20 is 7. -24 plus 0 is -24. 9 plus 10 is 19. And 6 plus -12 is -6. All right. As far as that all goes, it should be pretty, for lack of a better word, like similar to what we see in our regular arithmetic. So now let's go to matrix multiplication. And this is a little bit different probably than what you're used to. So to successfully multiply matrices, the number of columns in the first matrix must match the number of rows in the second matrix. Otherwise, you cannot multiply them. So the columns is the second number. The matrix, the rows is the first number. So here, the 3's match in the middle, so we can multiply it. And the resulting matrix size will be the 2 outside numbers, so 1 by 2. So let's look at this next one. The 5's match up in the middle, so we can multiply it. And I'll be left with a 4 by 2. In this case, since these do not match up in the middle, this is not going to work out for us, right? We call that usually undefined. Okay, so now let's actually look at how we multiply a matrix. So let's first check the sizes. This is 1 row by 3 columns by 3 rows by 2 columns. So this does match up, and we should get a 1 by 2 as an answer. Okay, I'm going to first line these up just in a slightly different order. I'm going to put the first matrix over here on the left, and I'm going to put the second matrix up here on the top. I think if you write it like that, it will help you kind of keep things clear as to what we get as a result. So the resulting one, right, will be this matrix. It's a 1 by 2 columns, so it'll look like that. Okay, the way we do it is we take the first row of the first matrix and multiply it by the first column of the second. So we do 6 times -1 is a -6, and we add it to the next values multiplied together. -3 times 5 is a -15, and adding it to 2 times -6 is -12. When I add those three quantities together, I get -33. Okay, then we do the same the next one. First row, second column. 5 times 7 is 42. -3 times 3 is -9, or plus a -9 if you want. 2 times 1, we're going to add 2. When you add those three quantities together, you get 35. So the resulting matrix is this 1 by 2, which has the numbers -33, 35. Okay, let's do the same down here. And this one we've got some variables, so it's okay to have variables in your answer. So I like the way we set it up. So first of all, this is a 3 by 3 times a 3 by 1, right, times a 3 by 1. So yes, the middle numbers match, we're good to go. So I'm going to rewrite the matrix, the first matrix over here on the left. And then I'm going to put the x, y, z up here. Okay, so for this first row, we're going to do the first row times the first column. So we're going to have -2x plus 1 times y is just y, and then 2 times z, which is plus 2z. Okay, now we go to the second row. Second row, and then the first column. 3 times x is 3x. 2 times y is plus 2y. 4 times z is plus 4z. Okay, and then we do the same thing with this last one. So 0 times x is 0x. I don't even need to write that. -2 times y is -2y. 4 times z is plus 4z. And this is our resulting matrix. As we said to begin with, or we can look at a 1 by 3. Notice, 3 by 1. It's got 3 rows and 1 column. So this is our answer. Okay. We got a few more to go over here. So I do think this order helps us. So 1, -4, 2, 6. And then -2, 3, -1, 5. So let's look at first row, first column. 1 times -2 is -2. -4 times 1 is +4. Okay, first row. Now in the second column, 1 times 3 is 3. -4 times 5 is a -20. Okay, now I go second row, first column. 2 times -2 is a -4. 6 times -1 is a -6. Okay, second row still, but second column. 2 times 3 is 6. 5 times 6 is 30. Okay. So now we're just saying, hey, this is equal to, let's add those things. So -2 plus 4 is 2. 3 minus 20 is -17. -4 minus 6 is -10. And 6 plus 30 is 36. And that's your final answer. Okay, same thing over here. So -2, 3, 1, 5. And then I've got 1, -4, 2, 6. Okay, first row, first column, I've got -2 times 1 is -2. 3 times 2 is 6. Okay, first row, second column, -2 times 4 is 8. 3 times 6 is 18. Okay, second row, first column. 1 times 1 is 1. 5 times 2 is 10. And then last but not least, second row, second column. 1 times 4 is -4. 5 times 6 is 30. Oh, I messed this up. There should have been a negative here. A -1, so that's positive. And then this would change to a negative. Okay, close call there, guys. So this is equivalent to -2 plus 6 is 4. 8 plus 18 is 26. -1 plus 10 is 9. 4 plus 30 is 34. Okay, let's look at the next one. 14, 7, -2, 6. We're going to multiply that by 1, 0, 0, 1. So 14 times 1 is 14. 7 times 0 is just 0. 14 times 0 is 0, but 7 times 1 is 7. Maybe I will actually write those zeros in so you know that we did do it. Okay, -2 times 1 is -2. 6 times 0 is 0. -2 times 0 is 0. 6 times 1 is 6. So notice, as we simplify things, we get 14, 7, -2, 6. What do you notice about this matrix? It is the same as what we put in. What we have over here on the left, this is called the identity matrix. And we're going to learn more about that next time. But I think it's just good for you to be familiar that it does exist. Okay, let's do this last one over here on the left. So -8, 9, 7, -8. And then I've got -8, -9, -7, -8. So -8 times -8 is 64. And 9 times 7 is -63. -8 times -9 is going to be a positive 72. 9 times a -8 is a -72. 7 times a -8 is equal to -56. And a -8 times a -7 is a positive 56. 7 times -9 is going to be -63. And -8 times a -8 is a positive 64. So we end up getting 1, 0, 0, 1. You should start to recognize that as the identity matrix, but what we're showing here is that there is something that we can multiply a matrix by to get the identity out, or basically the multiplicative identity out. Okay, so we did find, as we just looked here, that, hey, there is this identity thing, right? We usually use the letter I to represent that, but we call it the identity matrix. And what ends up happening is they're always square. It's like a 2 by 2, 3 by 3, 4 by 4. You've got ones along the diagonal, and you got zeros elsewhere. And then you can also take the identity out front, multiply it by. The inverse property is what we saw there in D. Is there's something we can take a matrix and multiply by the inverse. The way we represent that is A with a little -1 out there. So that's called the inverse of matrix A. So So the inverse of matrix A will also give us A at any. Okay. Commutative is something, if you look at C and D here, notice these are actually the same two matrices, but I just changed the way you multiply them. Did we get the same result? And here we did not, so that's where you gotta be careful with. Order is gonna matter when you do matrix multiplication. Like if you multiply something in the wrong order, you will get the wrong answer.